This kind of probability is where you have to figure out areas of shapes like this is, let's say, 8 by 10. And it's so easy for rectangles. It's just 80. 8 times 10 is 80. 80 square inches. But what if only this part right here was like your reward? You get some money if you get it in this area here. And let's say that it's only 3 by 3 by 3 by 3. That's because that's how squares work. Then the probability of hitting that, assuming it's random, again, if you can toss it, you wouldn't really be random. So it'd be more like you throw a ping pong ball in there and it bounces around and rolls around. You can't really control it. And all of a sudden it settles. If it settles in the red area, you win. Well, then probability, like I told you before, is always what you want over all the things that are possible. And what you want would be the square over what's possible is the big rectangle. And this is how I would want you to set them all up. You don't have to do this one because you're going to do one in a second. And the little square area is 3 by 3 is 9. Out of the rectangle area is 80. Then your probability of hitting that is 9 out of 80. Does that make sense to you? That's basically the problems that you have. The only other way we do it is, let's say it isn't shaded in there. Let's say it's shaded outside of there. Let's say it's shaded in this region out here. Now you have a much better chance of winning because you win if you hit the shaded region right. So again, what you would do is you'd set up what I want over what's possible. And what's possible is still 80, but what I want isn't 9 now. It's 80 minus the 9. See, it's almost all of the area on the top. It's not all 80, though, that makes you win. It'd be 80 minus this. If you haven't figured this out yet, the minus means like not. It's like the 80 is the area on top, but not the negative 9. Not the 9. What on earth was that? Okay. Are you turning it on?
No, I just turned it off.
Actually, did it make the noise or?
No, it was my notifications on.
Okay, all right. I do want you to have that on. The filter thing, turn the filter thing on.
Oh, sure.
And the reason, I just looked at an article the other day. I know they installed these things because of COVID, but they did a study just recently in elementary schools, and we're not any different really. It's just a bunch of kids sitting in a room. And that fan, that purifier thing, cut down absences by an average of 1 absence per student, as in less kids did get sick if there was a filter running. Because if you, let's say that you sneeze back there or somebody sneezes somewhere else, it gets sucked in there, gets cleaned, and then you don't end up breathing it in. So bottom line, I want that filter running back there. Okay, so we were doing the probability of hitting this blue shaded area here. And that's the harder kind because it's almost the whole area, but you subtract off the square. So that would be, let's see, what is 80 minus 9? That's 71, right? Out of 80. And you can leave your answers as fractions, so that'd be it. All right, let's see if you got this, but there's 2 other areas I got to make sure. You'll know rectangles, duh, you multiply them. You'll know squares, duh, you multiply them. But do you remember for circles? What's the area of a circle? Who remembers that little formula? Yes, Jackson. Pi r squared is correct. And so if the radius here was like 3, to do the area of this circle, r is 3, just put it right there. You can do 3 squared in your head, and then you got 9 pi. And so let's say that this was a circle inside of a circle. And your goal was to hit inside this red circle. Well, then it's always what you want over what's possible. And the possible is the big circle. Let's say that I tell you that radius is much bigger than 3. Looks like it's at least 7. Then what I want is right here. What's possible is the whole one. And you're going to put that here. Put what you want here. Put what's possible there. And then the pi's will cancel, by the way. And it'll just be a fraction. Give it a shot. It's just an area of a circle over an area of another circle. So Liam, what part do I want again? What do I want to hit here?
Shaded circle.
Yep, the red circle. What's possible is the black circle. And now, what was the area of that little red circle, Liam? Liam, you got this. Area's right here. Can you just simplify that to a number? 3 squared is 9 pi. So you just say 9 pi. Now I know you could take the time to multiply that by 3.14, but you wouldn't want to because there's going to be a pi on the bottom and then they'll just cancel. All right. Mauricio, do you know how to find the area of the bottom circle, the big one, the black circle?
Isn't it 49 pi?
It is. It's pi r squared again, but r in this case is 7. So it's 7 squared is 49. So it's 49 pi. Now when the pi's cancel, doink, doink, the answer is 9 over 49. That's your probability of hitting the circle in the circle. All right. Now I know that you guys took geometry last year. Like that's the normal course of things. Right before this class is usually geometry. Almost everybody in here just had geometry last year. But you still could have forgotten the pi r squared thing. And there's another one you might have forgotten. A triangle. It's not just base times height. Would you figure out the probability of hitting that 10 by 8 triangle? I know some of you know the secret to the triangle. I'll remind you in a minute. Find the probability of hitting that shaded region. It's always what you want over what's possible. Remind me to mark you back to that you're here. All right, so you're going to get called in for the first part?
Yeah.
Good. All right. So what you want here is the triangle, and if you just did 10 times 8, that's 80, and that'd be wrong. Alex Wilhelm, do you remember if it's not 80, what do you do for triangles?
The pi equation.
Nope, that would be for circles.
1/2.
It's 1/2 of that. So instead of 80, we're going to put 40. For triangles, you just go base times height, but then you cut it in half. All right. Logan, can you tell me the bigger one, the what's possible, which is the big rectangle on the bottom? Yes, 3 times 2 is 6. Add a couple zeros, 600. And then again, to make your life a little easier, don't forget you can cancel zeros. Like that. So it's 4 over 60. Ooh, and I cut both of those in half. That's 2 over 30. And you can cut them in half again. 1 over 15. Cool. That's your probability of hitting the triangle that was inside the rectangle. All right. Now, it's not like it's so much more complicated, but it is definitely different. If I shade this area in blue and I say, what's the probability of hitting the blue area? Then the way I would do it is take the possible, which is still 60. That's easy. And then I'd take, it's almost all, thank you, 600. You're right. The original was 600 before it canceled. I would take all of 600 is kind of all of 600 except, what do you have to do?
Have to
Subtract this triangle, which is 40. And there you go. Once you do that math, you'd have it. That may have been the shortest lesson all year, but that doesn't mean it's easy. I know that most of you got this, but not all of you. I need to do a couple more and actually have you try and actually have you compare answers with the kid next to you so that we see if we really got this. I'm fine with you leaving the answers, well, not like that, 60 minus 4. You should do that so there'd be 560 out of 600. I'm okay with you just simplifying them a little bit. Let's not stress too much about reducing the fractions all the way. But if you told the kid next to you, I got 56 over 60, what'd you get? And they were like, oh, I reduced it a little further. That'd be a good answer. So just try these two as nice, clean, normal, easy problems like this. This is going to be 10 by 12. Inside, we're going to have a circle that has a radius of 2. And we're going to say probability of hitting the circle. Give it a shot. And then here's one that's very similar, longer and skinnier. 10 by 3 with a triangle in it. That's 1 by 2. This time I want the probability, you know that it's almost the whole thing. You just are going to subtract out the triangle. All right, don't go too far. Just get this top one done first, the red one. Because in a minute, I'm going to have you compare that red picture answer with the kid next to you. So just do one of them. If you don't have it, try to look at theirs and learn from them. Okay, you're not using it as a phone, but I'm just getting borrow one instead. It looks less like you texting as your kids next to you. For today, you guys compare, please. Just that first one. Compare with the kid next to you, please. Zoom in on the first one. You can have a pie in your answer.
Isn't it pi r squared? So
Yeah,
2
but I
squared.
just left it as a
Oh, I'm not done yet.
4.
Yeah, it's 2 squared times pi.
Yeah.
And you
Pi
two guys.
squared and 2 squared.
That's a pie in the answer. That's fine.
Yeah, but you don't have to.
Oh, I thought that was all.
After the bottom
no.
one, 29/30.
All right. So for the top one, what you want is the circle, which is pi r squared, and r is 2, and then 2 squared is 4. So you could have had a 4 pi here. I'm going to put pi 4 just because I think a lot of people probably did that. I would be fine with that. You really should have 4 pi, but over 10 times 12 is 120. Could you reduce it? Yeah, I know. But roughly, that's what you should have done. Raise your hand if you had that one right. Cool. Then everybody try this one, which is definitely more complicated, but it doesn't have a pi in it at least. And then compare that one. Some kids aren't going to get the top of the fraction right. Just talk to them about it. Guys both got it? Check with each other.
You want the big figure? Yeah, so 29.
Okay, talk to each other. Don't make me talk to each other. Don't make me make you. Be nice, talk to each other. All right, so what you want on this one is not just the triangle. It's not just the triangle. If it was just the triangle, you'd go 2 times 1 is 2 for the triangle, but then you cut it in half, and the area of the triangle is just 1. But that would be wrong. That'd be the probability of hitting the triangle. The whole thing is 30, though. 3 times 10 is 30 for sure. So on the top, you just go 30. Because it's almost all of it, right? minus the triangles area, which was 1. So 29 out of 30. Raise your hand if you had that one right. Okay, cool. I think you get this. Now, good news on this is that this one is actually very commonly on the ACT. It's a good one to practice for the ACT test. It's also commonly something they want you to know on the MCA tests. And so this is like one of those, like, really, you're going to use this one on maybe that college entrance test someday to figure out what math class to place you in at St. Olaf College or wherever you're going. All right, so now there's a Schoology quiz. Everybody open up the Schoology quiz. I'll do the first one with you. Nice, easy day. Strasburg, could you read me number 1?
There's a big square that's shaded,
Is it actually a square or rectangle?
or rectangle.
Okay.
And it's got 9 and 15 on the sides, and then a smaller rectangle unshaded in it with 9 and 3 on the sides.
Is it really 9? Does it actually go the whole? Well, can I see? Let me see the picture.
It's 9 to 15.
I got it. Okay. So it's 9 in this direction by 3, was it?
Yeah.
Okay. And did they shade on the inside of the rectangle?
No, it's on the, not in the little rectangle, it's on the outside of it.
So it's like this?
Yeah.
Okay, gotcha. All right. Then it's always what you want over what's possible. And what's possible is 9 times 15. I'm not good at that in my head, but I can do it. 9 times 10 is 90. 9 times 5 is 45. So it's 90 plus 45. So that'd be 135. Can anybody verify that I did that right? Cool. Then what I want is not just the 9 times 3. That'd be if it was shaded inside it, but we shaded outside it. So we want to take the same 135, but take away, I won't win, I will not, the 9 times 3 is 27. So it's almost the whole area, but not the 27. 9 times 3 is 27. All right, so if you simplify this down, then what they were telling you to do is get it simplified all the way down. So if you don't know how to simplify the fraction, you can take it, turn it into a decimal is the safe way. Take a calculator and divide them. Because see, decimals, you don't have to reduce. So if you're worried about like whether you reduced it right, just make a decimal out of it and type it in as a decimal. Does it say anything about how many decimal places? 2 decimal places, okay. So again, if you round wrong, it's going to cost you, so be careful. I just put that in a calculator, but if you do this first, that'd be smart. Otherwise, you need parentheses around it. Because if you just typed 135 minus 27 divided by 135, your calculator is going to do that first. You don't want it to do that first. That's why you should do this first on your calculator, hit enter, or put that in parentheses. All right. There's number 1. I think you get the idea. If you get stuck, would you please come up and ask me? I'd be happy to help you. And that's it for this nice, easy day.